This is Algebra 2, Lesson 12-4, Inverse Matrices and Systems. In Chapter 3, we used row operations on a matrix to solve a system of equations. Now we'll solve systems by solving a matrix equation. Essentially, you can solve some matrix equations, AX equals B, by multiplying each side of the equation by the inverse of A to find X. Okay, basically, by multiplying both sides by the inverse, you get the identity matrix on the left-hand side. The identity matrix times X just gives you X. So the inverse of A times B will give you what X equals. So let's take a look at this. We're going to do it by hand, and we're going to use the calculator to do it. Therefore, you'll know how to do it both ways, because you're going to have to do it both ways on this test. So, what is the solution of the matrix equation? Let's look at letter A. First thing we need to do is evaluate the determinant of A and find the inverse. So we're going to do 4 times 2 minus 2 times 3. That's 8 minus 6, which is 2. So now to find my inverse, I'm going to have 1 over the determinant times the matrix, in this case 2, negative 2, negative 3, 4. Remember, you interchange these two numbers, make the other two numbers negative. So 1/2 of 2 is 1. 1/2 of negative 3 is negative 3/2. 1/2 of negative 2 is negative 1. 1/2 of 4 is 2. So there's my inverse matrix. Right? So that just is the inverse matrix. Okay. Now multiply each side of the equation by that inverse matrix. By multiplying it by the left side, all I end up with is X. By multiplying it by the right side, I will have 1, negative 3/2, and then negative 1, 2. And I'm going to multiply that by my original right-hand side here, which was negative 5, 2. So you multiply this by 5, 2. And we're going to do it by hand because it's fairly simple to do, fairly simple computation. So we're just going to do 1 times negative 5 plus negative 3/2 times 2. And then we're going to do negative 1 times 5 plus 2 times 2. So that will give us 5 plus negative 3 here, and negative 5 plus 4 here, and that will give us whoops, negative 5. That messes up everything. This should be negative 5, this should be positive. So that gives us negative 8 and 9. So our value for X is X equals 8 and 9. And there is your solution to your equation, your matrix equation. Okay. Now, using the calculator, you can do the exact same thing, just a little faster. Okay, so what I'm going to do here is X will equal the inverse 2, 3, 4, 6, the inverse of this times negative 7. And I don't care which calculator you put it in. You can put it in your calculator. You can get the same result either one. And when I put it in, strangely enough, when I put it in, I get error, singular matrix, which is an okay error to get because if you remember, a singular matrix means it has a determinant of 0. And if it has a determinant of 0, that means it has no inverse. And if it has no inverse, that means there's no solution. Okay, so here there's no solution. Okay, that's why it said some matrix equations can be solved by using the inverse, and some cannot, because if you have no unique solution, you can't solve it using the matrix. Okay, so let's take a look at a couple of other examples. All right, you can write a system of equations as a matrix equation. Okay, it's very simple to do. I have x plus 2y equals 5 and 3x plus 5y equals 14. You simply take your coefficients and put them here. This is your coefficient matrix. And you put your variables here, and you put your answers there. Okay? Coefficient matrix A, variable matrix A, constant matrix B. Very simple to do. So what is the matrix equation that corresponds to each one of these systems? So let's look at this first one. Let's do the coefficients first. This will be C, negative 7, 5, 1. There's my coefficient matrix. All I did was take the numbers in front of the variables. And then my variable matrix, X and Y. And that's going to equal my constant matrix, 8 and negative 2. Very simple to do. Straightforward. Not so hard at all. It's really easy to take an equation and get it into a matrix. for this next one here. Coefficients 1, 3, 5, -2, 1, -4, 7, 2, 0. Remember, you always have to have a placeholder. If there is no variable there, it still has to be a 0. And then we're going to have x, y, and z now. And then my constant terms are 12, -2, and 7. And there's your matrix equations. Simple enough. Now, if a coefficient matrix has an inverse, you can use it to find a unique solution to a system of equations. Remember, when we tried the other one, it had no inverse, therefore there was no unique solution. Okay, so solving a system with two equations, what is the solution to this system? First thing we're going to do is write it as a matrix equation. So we're going to do 9, 2, 3, 1, and then x, y, and that is going to equal 3, -6. There's my matrix equation. Then we're going to determine the inverse. And again, I'm going to do this one by hand, and then we'll do it with the calculator so that you know how to do it both ways. But you have to do it by hand because I'm going to make you do it by hand. So here's my determinant then is 9 times 1 minus 3 times 2, so 9 minus 6, which is 3. So I'm going to do 1 over 3 times 9 and 2 and 1, which means 1/3 of 9 is 3, and then 2/3, and then 1, and then 1. So there's my inverse. Okay. Oops, I messed that up. I forgot to switch the signs in them. Okay, we're going to do that. Back to the front open. I've got to do 1/3 times 1, 9. There we go. So it's 1/3, -2/3, -1, and 3. There we go. That's a better inverse. Right there. So there's my inverse. So multiply each side of the matrix equation by my inverse. Okay. So I now have xy will equal 1/3, -1, -2/3. 3 is going to be multiplied by 3/6. There we go. So if I do that correctly, it's 1/3 times 3 plus -2/3 times -6. And then it's -1 times 3 plus 3 times -6. So -1/3 times 3 is 1. -2/3 times -6 is 4. And -1 times 3 is -3. And times -6 times 3 is -15. So we're going to get 5 and -21. So the solution to this equation, okay, solve for xy. xy equals 5, 21. And that's how you do it the long way. And I will not make you do it 3 by 3 by hand. Okay? We'll make you do some other ones. And remember, the system has a determinant of 0, then there's no inverse matrix, and it has a unique solution. Alright, let's take a look at it. This system has a determinant of 0, and we just said that. Solving a system of 3 equations, right? This system is a matrix. The Levy coefficient matrix is matrix A, and the constant matrix B. If you're using the TI-84, if you're not using the TI-84, you can just plug in the inverse times the constant matrix. Okay? So, use these in your calculator to find the solution. Be happy you can use the calculator. Alright, so this first one here, I'm going to make a coefficient matrix 7, 3, 2, -2, 1, -8, 1, -4, 10. That's going to be x, y, z. And that's going to equal 30, So to solve this, x, y, z will equal 7, 3, 2, negative 2, 1, negative 8, 1, negative 4, 10, and we'll take the inverse of that times the coefficient matrix, which is 13.6, negative 13. So if we take that, plug it in our calculator, and multiply it, take the inverse of it. Okay, so I'm just going to plug this in as the matrix. And I get 7, 3, 2, 2, 8, 1, 10. And take the inverse of that. And multiply that by the 2 by 1 matrix. Which is 13, 26, negative 13. Do that, you get 9, 12, negative 7. Remember having to do the equations with three unknowns and trying to figure out all those numbers, and eliminating something else, and eliminating something else after that? It gets pretty ugly, doesn't it? Just to make it much faster. And there you have your answer. X, Y, Z is 9, negative 12, is 7. So, write my final answer, I should write X, Y, Z equals 9, negative 12, 7. Okay, let's take a look at the second one. Again, I'll do it in different colors so we can usually see. 1, 1, 1, 2, 1, 0, 1, 3, negative 3. X, 2, 5, 4. So you're going to do the inverse. 1, 1, 1, 2, 1, 0, 1, 3, negative 3. We're going to do the inverse of this times 2, 5, 15. And put it in on the calculator, the inverse of all of this. When you're doing it in fractions, guys, you want the answers in fractions and decimals. If your TI Inspire comes up as decimals and you cannot figure out how to get it to fractions, come see me. It's how it's broken. It's how settings are set. And I can't walk you through that here. I have to walk you through a class or the TI before. It's just hit math enter and we'll change it into fractions. Because the answers to this should be 5 fourths, 5 halves, and negative 7 fourths. So there you have your answer for that particular one. Okay? Real world problems. Yes, you have to get those too. A linen shop has several tables of sheets and towels on sale. The sheets are all priced the same, and so are the towels. Mario bought 3 sheets and 5 towels at a cost of $137.50. Marco bought 4 sheets and 2 towels at a cost of $52 and the price of each item. So, first thing first, always define your variables. So those sheets cost, and y is going to equal the towel cost. Next thing I'm going to do, I'm going to set up my equations. Let's see, let's set up one for Mario. Mario bought 3 sheets and 5 towels that cost $137.50. Marco bought 4 sheets and 2 towels that cost $115. Now remember before in Algebra 1, we took these two equations and we solved them as substitution for elimination. Now I can stick them into a matrix. So my matrix is 3, 5, 4, 2. Okay, and x, y. And that's going to equal 137.50 and 118. So to solve this, the inverse of A. So 3, 5, 4, 2, the inverse of this times 137.50 and 118. Put that in the calculator, and you should be able to quickly solve this. That will give you xy. So xy now equals 2250 and 14 hours. And since it is a word problem, we have to solve this in a complete sentence. So sheets cost $22.50, food towels cost 14 hours. And there you have it. Now, when the coefficient matrix of a system has an inverse, the system has a unique solution. Similarly, when the coefficient matrix does not have an inverse, the system does not have its unique solution. In that case, the system either has no solution or an infinite number of solutions. You should be able to look at a system and determine really quickly whether or not it has a unique solution or not. Okay? Let's take a look at this first system. 4, negative 2, 7. Negative 6x plus 1 equals 5. So we have 4, negative 2, negative 6. And all we have to do is determine the determinant. Okay, so 4 times 3 minus negative 6 times negative 2. So 12 minus 12 equals 0. So there's no inverse, so no unique solution. No inverse for any solution. So look at the second one here. 12, 8, 3, negative 7. 12 times negative 7 minus 3 times 8. 12 times negative 7 is negative 72. Times 5, which is 14. 84. Negative 4 minus 24. Okay, that's going to be 108. Right. So that means it does have a unique solution. It has an inverse. So there we go. And that is inverse matrices and systems.